students, today we will solve a problem on kinematic viscosity. So let's see what is the problem. The problem is hereby given as find the kinematic viscosity of an oil having density 981 kg per meter cube. The shear stress at a point in the oil is 0.2452 Newton per meter cube and the velocity gradient at that point is 0.2 per second. So at first we have to write the given data. So the given data are, what are the given data? Density rho equals to 981 kg per meter cube and shear stress tau equals to 0.2452 Newton per meter cube. Velocity gradient, that is we know du by dy, this is 0.2 per second. We know there is a relation between tau, mu and du dy, which is given as shear stress tau equals to mu du by dy, which is also known as Newton's law of viscosity. Now here the data given is tau equals to 0.2452. We don't know the value of mu. What is mu? Mu is coefficient of dynamic viscosity or coefficient of viscosity or viscosity. And du dy is given as 0.2. From here we can find the value of mu. So what will be the value of mu? The value of mu will be 1.226 Newton second per meter square. So here we got the density is 981 kg per meter cube. Shear stress tau is 0.2452 Newton per meter cube. Velocity gradient is du dy, that is 0.2 per second. So we know there is a formula of tau mu du dy, which is also known as Newton's law of viscosity, that is tau equals to mu into du dy. Here the value of tau is given, that is shear stress 0.2452. We don't know the value of mu. We have to find the value of mu, that is dynamic viscosity, and du dy is given as 0.2. From this relation we find that value of mu is 1.226 Newton second per meter square. Now we have to find the value of kinematic viscosity. We don't know what is the kinematic viscosity. Kinetic viscosity mu equals to mu by rho. So we have already knew this relation. That is where mu is kinematic viscosity, mu is dynamic viscosity and rho is density. So we got the value of mu just solving the problem, that is 1.226, and here the value of density is already given, that is 981. So by solving we found 0.125 into 10 to the power minus 2 meter square per second. From here we can write 0.125 into 10 to the power minus 2 into 10 to the power 4 centimeter square per second. So here we can write 12.5 centimeter square per second. We know 1 centimeter square per second equals to stroke. So there will be the value of nu, that is kinematic viscosity, is 12.5 centimeter square per second, or we can write the value of nu is 12.5 stroke. So this will be our answer. Hope you understand this problem. That's all for today's class. If you have any doubt, please feel free to ask me anything. If you like the video, please share with your friends. For more updates, subscribe my channel and don't forget to press the bell icon. Thanks for watching.